In this demo, I will show you how to use PyCloud to create distributed Python applications on Kubernetes. PyCloud is converting local function calls into network calls like HTTP, gRPC, or RabbitMQ messages, so we don't have to implement interfaces on our own. It also makes our application code much less complicated, so it's easier to maintain and to modify. Because we are starting from local monolithic code, we can test the application logic locally on our laptop or workstation and then move it into the cloud environment as distributed application and be sure that it all fits together. The scenario for demo is to create scalable ResNet service on Kubernetes, which will be returning the image labels if they reach the accuracy threshold. We want to be able to change the threshold in the runtime when the services are already scaled. I will be using Python 3.8 on my Ubuntu workstation. First, we have to install PyCloud framework. So I'm creating my free account on the PyCloud AI website. Now I'm downloading the installer that fits my operating system and version of Python. I'm starting the installer. Now we can check whether the PyCloud CLI works. We can double check with importing PyCloud library. Now let's create a Kubernetes cluster on Google Cloud Platform. And here is where the magic starts. We will be using single commands to deploy distributed microservices from a single Python file. I will show you later what's inside the file, but now let's see the effects. The application is now executed locally. You can see from logs that TensorFlow is in use and there is some inference. Now we can see the summary of the architecture. There are three services. There are some calls between them. The interfaces are mostly gRPC or HTTP, but there is one RabbitMQ connection. We will be using it to broadcast the accuracy threshold to all instances. So if you are happy with the architecture, you can accept it and proceed with deployment. PyCloud is building Docker images and it will push it to the registry. The cluster is almost ready. We have to wait for assignment of IP addresses of exposed services. Okay, we have the deployment summary. Let's send some requests to the API service with curl command. Believe me, there is an orange on that image, and as you can see, the returned label is also orange. Now let's check whether image of laptop will be also correctly recognized. Now let's log in into PyCloud monitoring console. We have 3 services marked with different colors. We can check the metrics of the endpoints, like latency and number of requests. There are also some custom metrics which can be created with 1 line of Python code each. Now it's time to scale our deployments. Let's scale ResNet into 4 instances and post-processing into 2 instances. Okay, all pods are running. We will now create a simple script to send requests in the loop. We will start 3 processes to make it parallel. Now we can see that all instances are in use, so the cluster is distributing the load across all pods. It's time to change the accuracy threshold and check what will happen. The accuracy for laptop JPEG is 0.7. Let's change the threshold to 0.8 with simple curl request. Now we can see another connection in the console. The last observed accuracy threshold is 0.8. We can also see that the metric of not classified images is increasing. This is because we are sending only the laptop image, which gets accuracy 0.7. And the service is now returning empty label. Let's finally jump to the code. In the annotations, we can see service identifiers like API, ResNet, and post-processing. So if function we are calling is assigned to different service, that would be translated into network call. We have one queue consumer, and we will be using broadcast command to deliver the message to all instances. So if the service is scaled, all pods will receive the broadcasted message. Here we have a local code execution which will serve as basic test and will build the distributed graph. Now I'm showing an important feature of PyCloud, which is launching on local Docker. You can launch your application on laptop or workstation and basically test it without the scalability feature before even creating Kubernetes environment. I can check the running Docker containers and compare it with Kubernetes pods. The difference is that some Kubernetes pods are scaled. I can also log in into the monitoring console of Docker deployment. And basically it's the same as the Kubernetes one, but without traffic right now. I hope you enjoyed the demo. Now I will mention features which were not presented but might be important for you. So first is that you can update single or few services without redeploying whole cluster. Another feature is that if you need some hardware acceleration, for example, CUDA drivers, you can specify custom-based image during deployment. Also, if you need some other libraries, they can be added to the custom base image. Another nice feature is ability to build the distributed application, store it in compressed file and deploy it later. So you can put it in Artifactory or pass to DevOps team so they will schedule the deployment of the cluster. So that's all from me. Thanks for watching. I hope you enjoyed the presentation and don't forget to visit pycloud.ai website. Thanks.